so in this video we're going to talk about the fundamental counting principle. And the fundamental counting principle is something that helps us to narrow things down. We have multiple different things we want to put together and the different ways that we can group them. So let's say we have 2 sweaters, 4 pair of pants, and 2 shoes. Well, you can start out with a sample space and draw it out. So here I've got my 2 sweaters, my 4 pair of pants, and my 2 shoes, my 2 pair of shoes. So for each sweater, I'm going to have a line going to my 4 pair of pants, and then from each pair of pants, I've got a different line going to each pair of shoes. And I'm going to replicate that for each sweater. So if you go back through at the end, and you can simply count the dots at your shoes, you find out that you have 1, 2, 3, 4, 5, 6, 7, 8. You have 8 different outfits stemming from this sweater, and another 1, 2, 3, 4, 5, 6, 7, 8 outfits stemming from this sweater. So that means that we have 16 outfits in total. Now, this took a while to draw, and it would have taken even longer had I had 5 or 6 different items that I was comparing, or more pants and shoes. So there's another way that you can do it. So if you draw your boxes to represent each item, so this is our first item, our second item, and our third item, and I'm going to put the number of things to represent each item. So for example, this box represents sweaters, and I had 2 sweaters. And this box represents pants. I had 4 pair of pants. And this box represents shoes, and I had 2 pair of shoes. So now, as you can see, there's dots in between. I can simply multiply each of my items. 2 times 4 is 8 times 2, and I still find out that there were 16 different ways or 16 different combinations that I could have found and had with my outfits. So instead of drawing out this diagram, I can multiply these. It kind of goes back to the multiplication rule, to find out how many different combinations I have. And this is a great thing to know about when you have 5 or 6 or 7 different things, or if your numbers are really large. So here's the basic rule that you follow. There are A ways of choosing one item, and B ways of choosing the second item, and C ways of choosing the third, and so on. Then the total number of possible outcomes is A times B times C. And then of course you can always find the probability of things, where the probability is the number of ways an event can happen over the total number of possible outcomes. So that's saying that if I wanted to find out just A ways of choosing something, we would find A over A times B times C. So let's do a problem and put this into action. And in this problem we're going to do, we're definitely going to be happy that we can use the fundamental counting principle and multiply versus having to draw tree diagrams for everything. So here's our example. A license plate can have 3 letters followed by 4 digits. So in example 1A, how many different license plates are possible? So for 3 letters, keep in mind when we talk about letters, we're talking about from A to Z. So that's 26 letters. So we would multiply 26 times 26 times 26. Now you're really glad you didn't have to draw a tree. Then we have 4 digits. Well, when we talk about digits, we're going from 0 to 9. So from 0 to 9, that's 10 digits. So now we're going to multiply 10 times 10 times 10 times 10. Again, really glad I didn't have to draw a tree to represent all this. So when I put these in a calculator and multiply all of them, I find out that the number of different license plates possible are 176,760,000 different license plates. This is why you can drive around and not see a repeated one, or why you won't see a repeated one. Then you throw in there the personalized ones, and you'll never see a repeated one. Now, 1AB. How many different license plates have no repeated letters or digits? So if we're not going to repeat a letter, then we're not going to use 26 each time. It's going to change. But the first one would be 26, but I don't want to repeat any letters. So my next one would be 25. My next one would be 24. This is because I'm not repeating. And of course, when you go A through Z, nothing repeats. Now, I don't want to repeat any digits either, and I'm still doing the same layout, 3 and 4. So my first one can have a choice of 10 different numbers. The next one only has 9 because I've already used one of them, and then 8, and then 7. And again, this decreases because I've already used one each time. So when I multiply all this out, whoops, I forgot my dots, I find out there's quite a bit fewer, 78,624,000. Notice the big difference when I don't have repeating versus when I do. Okay, then part C wants to know the probability that a license plate has no repeated letters or digits. So I'm going to take the probability that an event can happen, over the total number of possible outcomes, and I'm going to divide it. And when I divide it, I get this. This is my probability that a license plate has no repeated letters or digits. Now, I think you might have some more problems in your notes. Why don't you work on those for class tomorrow?